Okay, you are designing an airport for small planes. One kind of airplane that might use this field must reach a speed of 100 kilometers per hour before takeoff, and it can accelerate at 2 meters per second squared. If the runway is 150 meters long, can this airplane reach the proper speed to take off? All right, so we've got a speed before takeoff of 100 kilometers per hour, and it can accelerate at 2 meters per second squared. All right. What does speed before takeoff mean? What velocity is that? It stops first, then revs up the engines, and then it goes down the runway picking up speed, right? So what is 100 kilometers per hour in this case? It's the final velocity, right? So we have V equals 100 kilometers per hour. Now the problem with that is that it's not in standard units. Does everybody know how to convert from kilometers per hour to meters per second? What do you do? You're not everybody, okay. So let's have a look. 1 kilometer per hour. I want to get rid of hours, so I'm going to multiply by a form of 1, which has hours on the top and seconds on the bottom. What number has to go here in order for this to be, yes, 3600, right, or 3.6 times 10 cubed, right? Seconds. So I can now cancel out the hours, and I've got that being equal to 1 kilometer divided by 3.6 times 10 cubed seconds. What did I say K? What do I do with these metric prefixes? What do I do with them? What are they shorthand for? What's it shorthand for? K. Yeah? 10 cubed, right. So all I do is I say 10 cubed meters over 3.6 times 10 cubed seconds. The 10 cubes cancel, and I'm left with 1 over 3.6 meters per second. So in order to convert from kilometers per hour to meters per second, I just divide by 3.6. Okay? So I'm going to come over here and immediately convert, because I always forget to convert later on. So whenever I see something that isn't converted, I immediately convert it. So it's 100 divided by 3.6 meters per second. What is my initial velocity? 0, right. V naught equals 0 meters per second. What's my acceleration? It's given, isn't it? 2 meters per second squared. And I'm looking for the distance this thing requires to take off, right? I do know that the runway is 150 meters long, but I don't know if that's long enough. So really what I want to do is find how long does this runway have to be if this plane has to reach this speed before it can take off. So I've got V, V naught, A, and X. What don't I have? Time. So which equation do you think I should use? Yeah, David. Right, exactly. And I know that the beginning of the runway I'm going to set to be 0 meters, right? So, since I do not know the time, I'm going to use this one. This little sentence here is part of the problem solving. Just doing the algebra or the math is not enough. You need to say why you're going to do something. Now we're looking for x, so we need to transform this equation so that it says x equals something. So that's v squared minus v naught squared, subtracting v naught squared from both sides, divided by 2a, dividing both sides by 2a, equals x minus x naught. Fortunately, x naught is 0, so what I'm left with is x equals v squared minus v naught squared over 2a. Right? I have v naught squared is 0, so it's just v squared over 2a. So it's v squared over 2a. And I'm going to put the numbers in. V squared is 10 squared over 3.6 divided by 2 times 2, which is 4. So I'm going to put a 4 there, right? So this is, let's check the units. V squared meters squared seconds to the minus 2, and I'm dividing by meters per second squared. Meters seconds to the minus 2. Seconds to the minus 2 go away. The meters here cancel with that square, left with meters. That gives me the right number, right? So I'm going to do 3.6 times equals times 4 equals, I'll take the inverse and multiply it by 100. So that's 1, well that's not right. I've got a problem here, don't I? What have I done wrong? That should be 10 to the 4th, shouldn't it? Not 10 squared, because that's what it already is. So I made an error here. Right, that should be 10 to the 4th. So multiply that by 100 again, because I already multiplied it by 100. I saw it was 1.92 meters, and there's no way a plane can take off from 0 going to 100 kilometers an hour in just under 2 meters, right? So I asked myself, oh, is that reasonable? Uh-oh, that's not reasonable. And corrected myself. And because I was doing it out like this, I could easily see where I'd made my error, right? So now I'm going to come over here and I'm going to write down my answer, which is 192 meters. So the plane needs a runway length of 192 meters at a minimum to take off. And that is my answer. And I make it very clear that that's what my answer is. I put it in the context of the problem, right?